Hi everyone, welcome to CodeTav Management. I have created the new playlist, which is the backend engineering concepts. So here it is our first lecture for that playlist, the REST and gRPC APIs basic concepts. So I hope this will be very much beneficial for your upcoming interviews. So build the concepts. If anything new you know, that also you can put in the comment section. That will be beneficial for others as well. Okay. So in modern backend architecture, how your services talk to each other. So that is just as critical as the business logic inside them. So how much your business logic will be complicated, the communications can be complicated. Okay, so we are moving away from the monolithic applications where everything communicates via the local method calls and into distributed systems where communication happens over the network. That is via some REST or gRPC APIs. Okay, so here is in the depth breakdown. Yeah, I will discuss mainly two dominant communication paradigms, how they differ, and when to use them. Okay. So first of all, I will talk about the advanced REST means the representational state transfer. So you likely already know the basics of REST, I hope. So it uses the HTTP methods, get, post, put, delete, okay, to perform the root operations on resources, which can be represented as the JSON. So, however, in enterprise level, we need to look at the uh, Richardson maturity model actually. So, specifically level 2 and level 3 to build truly robust REST APIs. So, if you want to know about the Richardson maturity model, that also you can visit from the sites, or maybe in the next lecture I will also explain. Okay. So first of all, for this advanced REST, there are some things we need to consider. That's how your API design skill will be high, and it will improve your performance as well, better readability. Okay. So see, the first one I have added as the resource-oriented design. So, and here see nouns, not verbs. So what does it mean? Nouns, not verbs. That means the endpoints should be entities, like the endpoint should represent the entities, not the actions. Okay. Like sometimes we write the APIs with suppose get users endpoint or update order endpoint. That is not good. Okay. So like that is the not that's not the best practices. So what is the good practice? What is the good practice is like always use the HTTP methods what supports HTTP like get, and then just in the endpoint add like slash users. Okay. Suppose you want to update something, so then use the put method, then slash orders, then your unique ID or something like that, or your order ID. Okay. So that is the main fundamental thing you need to consider for designing any API. Okay. So just consider that and go through. Okay. Next is IREM potency. That also, like a crucial concept in distributed systems is that idempotency. And an operation is idempotent if making the same request multiple times produces the same result. That is the idempotent. So you have already know in your mathematics that what is the idempotent. So according to that, in our rest also, like get, put, delete, those are mathematically idempotent. Why those are idempotent? Because if a network call drops and client retries a put or get, then the system state remains consistent. No change will be happening. But in case of post, that is not idempotent. Why? Like retrying a post without safety mechanisms, like if you will manually add like idempotency key in header, then that's the different case. But if you will not add, then that can result in duplicate records, like charging a credit card twice. That will be not good. Okay. Next is hate OS. What is this? That means hypermedia as the engine of application state. So that is the level 3 of the Richardson maturity model. Okay. So a true REST API should be discoverable. When you request a resource, the API should return the data along with the links to other valid actions you can take on that resource. And it will minimize the hard coding of URLs on the client side. Okay. So it only will provide the links as well. Next is versioning strategies. So, like through the versioning strategies, like when APIs change, actually, like you must handle the versioning without breaking the existing clients. Like suppose for the first 6 months, client decided to do something with one API. Okay, but your other functionalities will be same, but they want some extra features for some specific regions, okay, with some another version of the same API. So then that versioning will come into your picture. Okay. So what are the common patterns? The first one is URI versioning, like API v1 users. In the same way, if you will create for another region, it can be like API v2 users or for separate time frames. Suppose from 2020 to 2030, that APIs will be used, and suppose 2030 to 2040, the separate versions will be used. I'm giving you 10 years span, but it can be like 2 months, 6 months span as well. So like API v2 users. Then query parameter versioning, you know what is the query parameter. So then like API slash users, then question mark, then version 1, 2, 3 in that. Next is content negotiation via headers. So accept like application, we generally do application.json format. Okay. So like via headers also like content also you can uh, add like accept application vnd.company.v1 plus JSON or v2.json, something like that. So that's the basic advanced REST concepts. Okay. So if you want to know more, I can yeah, obviously like in the next lecture, I will explain with some code snippets as well. Okay, but here mainly the basic understanding things, right? So next is the gRPC. So gRPC means Google Remote Procedure Call. So while REST is the undisputed king of client to server communications, like a web browser talking to a backend, but it is relatively slow and bulky for server to server, like microservice to microservice communications. So this is where gRPC come into picture. So gRPC is very high performance RPC framework developed by Google. Instead of focusing on resources, it focuses on actions or procedures. Okay. So next is like the protocol buffers, like the ProtoBuf. So we know like in REST we generally use the JSON, but gRPC uses the ProtoBuf as its interface definition language. Ideal. ProtoBuf. I will show you what is the structure of the profile. Okay. So you write a protofile defining your data structures and service methods. But it is strictly typed actually. The contract is absolute. You compile the .proto file to automatically generate the client stubs and server boilerplate in almost any language, Java, Go, Python, anything will be applicable. And binary payload, like JSON is text-based and requires heavy parsing, but Protobuf actually serializes data into a highly compressed binary format. So it is significantly faster to serialize and deserialize and uses much less network bandwidth. So that's why it is first. So first is strictly typed, next is binary payload. And because of this binary payload, serializations will be faster and deserializations will be faster. And that's why less network bandwidth it will take. That's why it is more faster. Next is HTTP 2 under the hood. Like REST traditionally uses the HTTP 1.1, but gRPC mandates the HTTP 2. So what was the problem at the HTTP 1.1 structure? So the main problem is head of line blocking. Means One request must finish before the next begins on the same TCP connections. Okay, but HTTP2 allows multiplexing. What is this multiplexing? Multiplexing means like you can send multiple requests and responses in parallel over a single connection. So that's how parallelly you can do multiple request response communications. So in that way, it reduces the latency. Next, first class streaming. gRPC supports four types of communication imminently. First one is unary, that means standard request response like REST. Second is server streaming, means client send one request and server sends back stream of data. Okay. Now client streaming. So client sends the stream of data, but server responds once. And bidirectional streaming, like both client and server sends or streams of data. Okay. And it will be independent over a persistent connections. And they also can receive stream of data. Okay. Now, when you will take the architectural decision, like then you need to decide like you need to use REST or gRPC. Like how you can decide that based on this feature. So first one is payload. If JSON structure will be utilized, then REST is better. If gRPC, then you need to use the binary ProtoBuf file. Okay. Now protocol. Usually, I have told you that REST use the HTTP 1.1, but gRPC use HTTP 2. Architecture fit, that is the public facing APIs. When web mobile clients, then you need to use REST. But when internal microservice communications will be happen, when polyglot environments, then you need to use the gRPC. Now performance is moderate in terms of REST, and in case of gRPC, it is high, low latency and high throughput. Human readable, yeah, REST is yes, easy to debug in Postman, but gRPC requires a specializing tool to decode, as there will be some binary, right? So it will not human readable. Then flexibility, high. Clients can parse loosely, but strict. Here for gRPC, we need exact dot proto contract match. So like you use the REST or GraphQL. GraphQL I have not discussed here. So GraphQL also I will discuss in separate lecture. So GraphQL or REST you can use for your external API gateway where front ends and third-party consumers interact with your system. And once the request process the gateway into your internal network, like when you do the internal microservice communication, you can translate it into gRPC for first communication between your internal microservices. Okay, so that's the funda of this REST and gRPC APIs. Where when you will use the REST, when you will use the gRPC. Okay. Next, I will mainly discuss again the advanced REST with like how the idempotency key will be come into picture, how the HOAS is considerable, like how you will use that HOAS. Next, I will also discuss about the gRPC with like the proto contact, like how you will write the proto file. Okay. Then how to do the Java implementation of that gRPC. Okay. So with some simple example, I will show you. Okay. So for now, if you have any other question, then you can comment below. I will definitely discuss about those topics. Okay. Thanks everyone. Bye, and don't forget to do like, share, subscribe. Okay. That will motivate me. Thank you everyone. Bye.